We're swimming in numbers every single day, in the news, online, everywhere. But what do they really mean? Well, today, we're going to pull back the curtain on a core idea in statistics called interval estimation. And trust me, it's the secret key to actually understanding the numbers that shape our world. So, let's dive right in.
You've heard this a million times, right? Some poll comes out, gives you the super precise number, and then they tack on that little phrase, margin of error. It sounds all official, but what is it really telling us? Does it just mean the real number is somewhere between 41% and 47%? Well, yeah, pretty much. But the story of why that is and how it works is way more interesting and powerful than you might think.
So here's the big problem. If we want to know what an entire country thinks about something, or how many customers love a new product, we're faced with a basically impossible task, right? I mean, you can't ask every single person. It would cost a fortune and take forever. So how in the world do we get a reliable answer? We do it by taking a small, random slice of that huge group, what we call a sample. And from that little sample, we calculate our single best guess. In the world of stats, this is called a point estimate. It's our starting point. It's our first shot at trying to pin down the truth about the whole population just based on the tiny piece we were able to look at.
Okay, to really get how we go from that one little guess to a much more useful answer, I want you to imagine something. This is a great metaphor that's going to guide us through the rest of this. Picture this. You're trying to catch a fish in a really murky lake. You know the fish is in there somewhere, but you can't see a thing. You've got two tools to choose from, a spear or a net.
The spear, that's our point estimate. It's a single number, super precise. You throw it at one exact spot. But what's the problem? In a murky lake, you're almost definitely going to miss. Now the net, that's what we call a confidence interval. It's not as precise, sure. It covers a much wider area, but because of that, it's way more likely to actually catch the fish. And that's the crucial trade-off right there. We give up a tiny bit of precision to gain a whole lot of confidence.
This quote from our source material just hits the nail on the head, doesn't it? A single number feels confident, but it's really just a fragile guess. That range of numbers, the net, is a much more honest and useful tool for finding the truth when you're dealing with uncertainty. So the big question is, how do we build that net?
So how do we actually weave this statistical net? It's not some kind of dark magic, I promise. It's really built from three pretty simple, logical ingredients. Let's break down what they are.
First up, you've got the point estimate, which we've already met. This is the number you get right from your sample data, and it becomes the very center of your net. You can think of it as the spot you were aiming for when you first cast it out. The second ingredient is the margin of error. This is what decides how big your net is going to be. It's that plus or minus 3% we talked about with the political poll. It's basically the amount of wiggle room we build around our best guess, just to account for the fact that, hey, our sample isn't the entire population.
And the final piece of the puzzle is the confidence level. Now, this one is a little tricky, but it's so important. A 95% confidence level doesn't mean there's a 95% chance this specific net we just made caught the fish. What it really is a statement about how reliable our method is. It means if we were to do this whole process 100 times and cast 100 different nets, we'd expect about 95 of them to capture the real answer. It's a long-term success rate.
And when you put it all together, the whole idea is actually beautifully simple. You just take your best guess, that's your point estimate, and then you add and subtract your wiggle room, the margin of error. That's it. That is the recipe for building our net.
Okay, so the theory is great and all, but let's actually see this net in action. Let's make it real. We're going to walk through an example from our source material about a survey of women golfers. So the question was pretty specific. Are you satisfied with how easy it is to get a tee time? Our goal here is to take the answers from just a sample of women golfers and use them to build a confidence interval that estimates how all women golfers feel.
All right, first piece of information we need is our sample size. In this survey, they talked to 900 women golfers. In statistics, we call this N, and it's a really crucial number for our calculations.
Next up, the results. Out of those 900 women surveyed, 396 of them said, yep, I'm satisfied. Okay, perfect. Now we have the raw ingredients we need to start building our net.
We're just going to follow a super simple 4-step recipe. First, we find our point estimate, our spear. Second, we'll pick a really standard 95% confidence level. Third, we'll calculate our margin of error. And then finally, we just put it all together. Easy.
Step 1 is a breeze. We just take the number of satisfied golfers, 396, and divide it by the total number we surveyed, 900. And that gives us 0.44, or 44%. That is our single best guess. That's our spear, aimed right at the 44% more.
Step 3 involves a little bit of math behind the scenes, but don't worry about that. The important part is the result. The calculation tells us that our margin of error, our wiggle room, is plus or minus 3.24%. This tells us exactly how big to make our net.
And now the final step. We put it all together. We take our 44% and we subtract 3.24% to get the bottom of our range, and we add 3.24% to get the top. And that gives us our final answer. We are 95% confident that the true percentage of all satisfied women golfers is somewhere between 40.76% and 47.24%. And just like that, we've successfully cast our net.
So, okay, we built one net for one survey about golfers. Big deal, right? Well, yeah, actually, it's a huge deal because this concept is everywhere. And once you get it, you'll be able to make sense of everything from news headlines to major scientific breakthroughs.
Seriously, you will see this net all over the place. In political polling, telling you the real range of support for a candidate. In medical studies, giving a range for how effective a new drug is. Companies use it for market research. Scientists use it in their experiments. It's even used in factories for quality control. This net is truly one of the most basic and powerful tools for understanding any claim that's based on data.
And that's really the big idea here. The world is a complicated place, and any data we get from a sample is going to have some uncertainty baked into it. A single number, a point estimate, tries to hide that uncertainty, but a confidence interval does the exact opposite. It puts that uncertainty right out in the open. It gives us an honest, plausible range for where the truth likely is, which is so much more valuable than a single number that's almost guaranteed to be a little bit wrong.
So, I'll leave you with this question. The next time someone throws a single number at you, a single statistic, are you going to just take it at face value? Or are you going to look for the context? Are you going to settle for the simple sphere? Or are you going to ask for the wisdom of the net?